Our second homework from this unit is still not difficult. We're going to graph. We're going to remember part of algebra, how we learn how to graph back in algebra, but we're also going to look at how we see it in stats. We're going to graph a line given 2 points, the line on the line, or the slope-intercept form of the line. So I'm just going to give you guys the equation. Here I have two examples here. The first one, I have y is equal to 3 plus x. Okay. Now, two ways how to do this. And one thing I want to emphasize as well. Here I label everything. You notice how I label everything here for you. Do you see the measurements of on my x-axis, the measurement of my y-axis? However, I could have not label everything. You guys are in stats. I could have just gone like this. See how I'm erasing some of my labels. I could have erased all this. Sometimes in stats, you guys will see that. The way you guys are supposed to see this, the way you guys need to see it is, you count the spaces. There's 10 spaces from 0 to 5. There's 10 spaces, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, what's 5 divided by 10? Well, 5 divided by 10 is 1/2. So that means each of these spaces is 1/2. So that's where we get that this is 1, this is 2, this is 3, this is 4, and that's obviously 5. We find out how much is each of those spaces. We found out it was 1/2 because there were 10 spaces. Now, what if, let me just say, what if I give you an equation like this? And then I only do 3 markings, and then I said this is 6. Then you count, okay? There's 3 markings, there's 3 spaces. 6 divided by 3 is 2. So each of these is 2. So again, you have to count the spaces. What's the big number? What's the at the end? And then divide it by how many spaces. Okay. So that's the statistical way. So let me come back. Let me relabel everything. Like I said, I might give it everything label, I might not. Now, the way we do this, because we're not afraid of fractions, in stats, we're not afraid of fractions, we're going to find 2 points. In order for us to graph a line, we need to find 2 points. I'm going to let, for my first one, I'm going to let x equal 0. That's going to give me a point. And for the next one, I'm going to let x equals 1. And that's going to give me 2 points. Again, I'm not afraid of fractions. I'm not afraid of decimals. So for my first point, I said we're going to let x equal 0. So x is equal to 0. I'm going to rewrite my equation. Y is equal to 3 plus x. But instead of x, I'm going to write 0. So I have that y is equal to 3 plus 0. But isn't 3 plus 0, 3? So I have my value of x. I came out with the value of y. So that gives me the point 0, 3. X equals 0, y equals 3. That gives me a point. I can easily plot that point right there. Now for my next point, I'm going to let x equals to 1. So I'm going to go x is equal to 1. So I'm going to rewrite the equation. Y equals 3 plus x, but instead of x, I'm going to write 1. So I'm going to write this as y is equal to 3 plus 1. And I know 3 plus 1 is 4. So that gives me the point 1, 4. I can easily plot that point. Boom, it's right there. If I would have been dealing with decimals, not a big deal. We can do that. Now I have 2 points. I'm just going to connect them with a line. That's it. Now, another way, let me show you guys another thing here. Another way we could have done this, using what you guys learned in Algebra 2, remembered arithmetic sequences. You guys remember that? Geometric sequence, arithmetic sequence. Now, to be honest, The way we could have done this is looking at this point, right? My beta 0, the point, my starting point. We call that the y-intercept. Remember it in algebra, you guys call that the y-intercept, which is 0, 3. My slope, the number in front of x, it's a 1 right now, right? So write it as a fraction. My slope is 1 over 1. Now, this thing on the top, let me call it dy, is the difference of y. This number at the bottom, let me call it dx, is the difference of x. As a matter of fact, as a preview of calculus, we deal with calculus with slope. That's really what calculus is all about. But in slope, we're not going to call it slope. We're going to call it derivative. In calculus, we call it derivative, which is dy over dx, which is the difference of y over the difference of x. That's really it. Calculus is mainly derivative. Okay, so I just showed you guys how to write slope in calculus. So preview of calculus. Okay, so now what does this mean? My difference of the y is 1. So on my y values, let me add 1. So we start with 3, so let me add 1. 4, 5, 6, 7, 8, as many points as I want. Not only could I add 1 to go here, I could have subtracted 1 to go backwards. So 3 minus 1 is 2. Oops. 3 minus 1 is 2. Minus 1 is 1. Minus 1 is 0. Right? Add 1 to go down or subtract 1 to go up here. Now on my axis is also 1. That's another way we could have drawn this. Starting from x, add 1. So 1, 2, 3. Go the other way, subtract 1. Negative 1, negative 2, negative 3. Guess what? That gave me a bunch of points. It gave me negative 3, 0, 2, 1, negative 1, 2, 0, 3, 1, 4, 2, 5, and then 3, 6, which is not on the graph. Notice how I came out with a bunch of points. We could have done that as well. You learned back in algebra that the equation of the line are basically the solutions that make that equation true, right? Any point on the line make that equation true. And they happen to look like a line. That's why we call it a linear equation. So you guys are like, Mr. Leonzo, so how can I do question number 2 using that? Okay. My initial point is 0, 0.5. We can do that. 0, 0.5. Again, don't be afraid of decimals. My slope is 3.25 over 1. So my difference of the y's, add 3.25. So let's see, 0.5 plus 3.25. Like I said, use a calculator, I get 3.75. Right? 0.5 plus 3.25. Now add 3.25 again. That gives me 7. Plus 3.25 again, that gives me 10.25. What if I wanted to go backwards? Okay, so starting at 0.5, subtract 3.25. So that gives me negative 2.75. Subtract 3.25 again. That gives me a negative 6 and on so far, so forth. That was my difference of the y. My difference of the x is 1, right? So from the center here, from 0, add 1. So 2, 3. Sorry, from 0 to go the other way, subtract 1. Can you plug in any of those points? Negative 2, negative 6. Nope, doesn't go in there. Negative 1, negative 2.75. Yeah. I see my -1 on the X. Now my Y. Where is negative 2.75? I see that's -2, that's negative 2.5, that's -3. So wouldn't it be about right there? Yes. The other point is 0, 0.5. So I see 0, 0.5. And the other point I get 1, 3.75. So 1 and 3.75. And then the other points I cannot graph. Good. Like I said, we're not afraid of decimals. We're in stats. Now you guys are like, okay, I could have done that. Could I have also done the other way you did, Mr. Leonzo? Let x equals 0, let x equals 1. Let x equals 0. Let x equals 1. Yeah. If we went and let x equals 0, it would have given us the point 0, 0.5, which you guys see there. What if we let x equals 1? That would have given us the point 1 and 3.75, which you guys see there. Graph those 2 points, draw a line that goes through them. Not a big deal. Like I said, we are in stats, so we're not afraid of decimals. This is how we do it.